Good evening, ladies and gentlemen. I really appreciate the given opportunity to present my research in this prestigious conference of the 8th World Congress on Neurology and Therapeutics. I really hope to participate in this conference on site, but the technical issues hindered me. I really want to participate in the next conference on site. First of all, my research is about using the theta and alpha ratio to detect the frontotemporal dementia. I will briefly introduce the concept of my idea first. The frontotemporal dementia has been relatively less investigated compared to some other dementias such as Alzheimer's or Parkinson's. However, it has a very distinctive pathology so that it is needed to figure out some effective markers to detect this frontotemporal dementia effectively, such as EEG markers. And the theta and alpha ratio has been figured out to effectively detect the Alzheimer's or Parkinson's, but not the frontotemporal dementia. So there has been no previous research regarding the frontotemporal dementia using this index. In this research, my objective is to figure out whether the theta and alpha ratio could detect the frontotemporal dementia. So I extracted the spectral power from the EEG datasets using the fast Fourier transform. And then I compared two referencing methods. One is the infinity reference, or REST in EEG lab plugin, and the average reference. So that this might compensate for some weak points of using the low density electrodes in my research. So first of all, as a result, I visualized the spectral power density between two groups. And I found that the FTD group or the frontotemporal dementia group had the enhanced theta wave and the lowered alpha wave. But there was no very significant difference between these two waves. So the important point is that when we use only the separate spectral power, it might be not very effective to detect the dementia. However, when we combine these two ratios to amplify the differences as a theta and alpha ratio, it might be effective to detect the frontotemporal dementia. So based on this background, I applied the Mann-Whitney U-test to find some significant differences. And I figured out that for the every lobar region of the frontal, central, parietal, occipital, and the temporal region, I found that the theta and alpha ratios were significantly increased in the FTD group compared to the control group. And one of the interesting points is that also the occipital alpha power has been decreased, which might be somehow consistent with the occipital theta and alpha ratio. And then I used the precision recall curve to compare the occipital alpha power and the occipital theta and alpha ratio to figure out which is more superior. So as a result, I found that for both referencing methods, the occipital theta and alpha ratio was superior to the occipital alpha power. The occipital theta and alpha ratio has a larger area under the curve of this precision recall curve than the occipital alpha power, and also it had the higher recall with no false positives compared to the occipital alpha power. And then I measured some representative diagnostic values of these regional indexes of theta and alpha ratio. So by using the maximized Uden index, I estimated the area under the curve of the receiver operating characteristic curves and specificity, sensitivity, cutoff points, positive predictive value, and the negative predictive values among the all original electrodes indexes. I believe that this might provide some opportunities for other scientists to compare these values with other indexes, such as the fMRI's functional connectivity or some other EEG combined indexes to make a more accurate and effective diagnosis using the neuroimaging methods. And then I applied the multiple regression analysis to figure out among these indexes which is the most superior to detect the presence of the frontotemporal dementia. And I found that, surprisingly, the frontal theta alpha ratio was the only significant variable that affects the presence of the the frontotemporal dementia. So when the frontal theta and alpha ratio was increased, the probability of the frontotemporal dementia was increased. These results were consistent among two referencing methods, infinity referencing and the average referencing. So in the discussion, I found that the theta and alpha ratio was more effective than separate alpha and theta spectral power to differentiate patients with FTD from healthy controls in every lobar region. Especially the frontal theta and alpha ratio was the best to predict the probability of the FTD. Such successful detection of FTD by theta and alpha ratio was consistent with both infinity reference and average reference. So this might compensate for some weak points of the weak approximations of the low density electrodes. But of course, there are some limitations in my research. First, a larger sample sizes might be needed to apply this index into more accurate methods such as deep learning or some other machine learning methods to make a more accurate and effective diagnostic method. And also, we need some clear explanation for the increased theta alpha ratio in every lobar region. Previous researchers have found that the occipital region is not affected by the frontotemporal dementia. However, for my data sets, the occipital region was significantly influenced by the presence of the frontotemporal dementia. This might be explained by some interference effects of other lobar regions as an EEG signals, but it's not very valid and clear explanation for this difference. So a further understanding of the biological and neurophysiological mechanisms underlying fluctuations in these brain waves is needed to fully utilize spectral power ratio such as the theta alpha ratio as as an inexpensive, convenient, and simple diagnostic tool for FTD. Thank you for the listening.